Hello students. Today we're going to be looking at 2.6 solving proportions. Proportions is something that you guys probably saw a lot of in 6th or 7th grade, probably 7th grade. We're taking kind of the same idea that you guys have seen before and kind of just applying it to bigger and bigger situations. So kind of the the whole really overarching rule of proportions is that in order for a proportion to be true, okay, the cross products of a proportion are equal. That always has to be true. So you can see that example there. I'll make a little bit bigger one here. Is that if you see something like 2/3 and say it has to be equal to 6 over something, if we go ahead and try the cross products, 6 times 3 is going to be 18. And then 2 times something has to also equal that 18. That'll be 9. You guys may have known that right as I was writing it. But if we try to say that 2 over 3 is equal to 6 over, I don't know, 11, maybe you don't know if that's true or not right off the bat. Just check the cross products. 2 times 11 is going to be 22. And then you're left to find out, does it equal that other cross product, which 6 times 3 is 18? It does not. So this whole thing cannot be a proportion. So that's going to be true no matter what you're looking at or what situation you're looking at with proportions. Now, just a quick refresher here for kind of how these proportions work and then in the form of an equation. If you have to find the x of a proportion, you can kind of say what you guys might be used to from kind of the 7th grade was the first time you saw proportions, you saw them where you're probably doubling or tripling. The first time you learn them, you'd see something like 15 over 6 equals 30 over something. And you're able to say, okay, well, that's times 2. So this has to be times 2. And that would be 12. Great. But now we're going to be focusing on that cross product because we're sitting in situations where you cannot very easily determine 15 times something equals 1 or equals 25. It would be 1 and 2/3. And I don't think we want to multiply 6 by 1 and 2/3. You're going to be dealing with decimals and fractions. So the easier way to do that is to use the cross multiples. So 25 times 6 has to equal 15 times x. Okay? In order for this to be a proportion, whatever that x is going to be, we're going to find it by knowing that it has to be equal to 25 times 6. 25 times 6 is going to be 150. That's got to equal 15x. And all we have to do to finish that off is divide by the 15, like any other one-step equation we've seen, and we get the x to equal 10. Okay, so we're going to be using that main rule of proportions to kind of be used to be walking through these equations, setting these equations up, and then being able to solve them. Okay, just like this other side over here. So I've got 15 times 45. And I don't know what that x is, but I know that that cross product has to equal 25 times x. Okay? So that 15 times 45 is going to be 675. That has to equal 25x. So then all I need to do with the one step is divide by 25. And I will end up getting 27. So I end up with 27 as my x, and that will make that proportion true. Okay? All right, so where we're going with this, we're seeing things more like this at this point. Okay? We're going to be seeing things where there's going to be full expressions involved. So if I've got 2x minus 3 times 9, where we have to be careful here is it is 9 times this entire top. It's not just 9 times 2x and then the 3 is hanging out. It's going to be 9 times the entire top of 2x minus 3, and that has to equal the 24 times x. So just like that, those last couple examples, we set up the equation. There just is more going on in this equation. Okay, so I'm going to distribute that 9. So 9 times 2x is going to give me 18x, and 9 times negative 3 is going to give me negative 27 or minus 27, and that has to be equal to my 24x. Okay, now we're at a two-step equation. I am going to get my 18x over to the other side, since that negative 27 is already one constant, so we'll leave it there. So I'm going to subtract my 18x from both sides, and then I'm going to be left with a negative 27 on the left, having to equal 24, or not 24, excuse me, having to equal 6x now on the right. And the last step is to go ahead and divide by 6. And what that is going to get me is going to be a negative 4.5. And that is what the x will equal. Okay, we're just going to kind of show setting this next one up. So as far as solving the equations go, the algebra side of it, we've seen all of this. We may not be masters at it yet, that's fine. But the new part today is making sure we know how to set that equation up. Excuse me. So to set this one up, I've got 4 times that entire bottom of 4x plus 3. So it's going to be 4 times a 4x plus 3 on the left-hand side, equaling 9 times the entire 2x minus 5 on the right-hand side. Okay, and then to solve this, or to finish it, I should say, not finish it, but to start solving this, we'll distribute that 4. We would have 16x plus 12, and then 18x minus 45. And you would be able to solve this from here. I'm not going to finish this one because I'm going to keep this video kind of short. So from here, you will be able to solve for x. Word problems. Okay, where we run into some issues with word problems, now you are responsible for setting the proportion up. That is probably where we run into the most issues in this section. Once you get used to the cross multiplying, it's the same thing every time as far as solving those proportions. But setting them up can be tricky with what numbers go where. So parts of Mexico City are sinking at a rate of 140 centimeters every 5 years. If this rate remains constant, how many centimeters will the city sink in the next 12 years? Well, what we have to notice in order to set this proportion up correctly, what we have to take note of is there's going to be 2 different labels going on. In this situation, we are talking about 140 centimeters over a 5-year span. And then they're asking us how many centimeters. Whenever they ask you how many of something, that's where your unknown is. Okay, so that's going to be what our variable is going to be, is that second number of centimeters. And then they're talking about 12 years. So using the rate of 140 centimeters for every 5 years, we're going to set up a proportion to figure out what will happen in 12 years. Of course, they're going to say things like if it remains constant. So what that means is assuming that this pattern continues, assuming that this rate is going to continue to carry out on a yearly basis, in 12 years, we should be able to figure out exactly how much sinking will go on underneath parts of Mexico City. So you can go a few different ways. For me personally, the easiest way is to kind of take the centimeters over the years. So that's going to be one of the rates, and set it equal to the other rate, centimeters over the years. So kind of what we're doing is we're taking situation number 1 and setting it equal to situation number 2. What else you can do is you can relate the centimeters to themselves and set them equal to the years related to themselves. What has to happen here, though, where you need to be careful, is we have to make sure that the top is one of the situations and the bottom is the other. So what I mean by that is if I'm going to put 5 centimeters, or excuse me, 140 centimeters up top, then the fact that it's paired with happening every 5 years, the top of the right side has to be the 5. Okay, so you can put both centimeters into one ratio on the left and leave the years on a ratio on the right, but you have to make sure that the top is one of those situations and the bottom is the other one. So what we would look like here, for the centimeters over years, I'm going to take my 140 centimeters for every 5 years and set it equal to the fact that the unknown is the second number of centimeters. So we don't know how many centimeters is going to happen over 12 years. So that's one of your proportions you could set up. The other one, we've already kind of started it. It'll be 140 over 5 equal to, we make sure the years are on top. Oops, I'm sorry. I already wrote that one wrong. Mistake, not 140 over 5. It's 140 over our unknown. That was my fault. It's 140 over the unknown. That is the number of centimeters that we don't know. Equal to 5 years has to go on top because it's paired with 140 over 12 years. Now, when we go ahead and actually look at these two things, when we see the cross multiples, so this would be 140 times 12, all equal to 5x. On the other side, 140 times 12 equal to 5x. So the 140 times 12 is 1,680 equal to 5x. So you can see, even when you do two different proportion setups, you're going to come up with the same equation. So then that x is going to be the same. If we divide by 5, it's going to be 336. So no matter which one of these you have set up, your x will equal 336. So it is going to sink 336 centimeters over a 12-year span. Okay, so you can set this up a number of ways. And just for a side note here, these can all be flipped. They can all be reciprocals of each other. This one could be 5 over 140 as long as the right side is 12 over x. And over here it could be x over 140 as long as the right side is 12 over 5. So you don't need to memorize all of this. All of these different proportions, you don't need to memorize the fact that it could look all these different ways. I'm just showing you that there's a number of ways you could correctly set these proportions up, and you'll always come to this answer of 336 in this scenario. Okay, so the last one, let's just set this proportion out. Actually, all they're doing is asking you, let's just set this one up. So when we're talking about percentages, so 12% of the coins produced by the US Mint have been quarters. Well, whenever we're talking percentages, that's going to be 12 out of 100. So 12% of all 100, 12% of each 100 coins made have been quarters. So this is going to be quarters compared to coins. And that's going to equal, if the mint continues to make coins at the same rate, again, that's the same wording as that last problem. If this rate continues, this proportion will hold true. Which proportion could be used to find the number of billions of quarters Q, so that's our unknown, that will be produced in 2020 if the mint produces a total of 25 billion coins. So if we do quarters over coins on the left, with that percentage making it 12 out of 100, we have to do quarters over coins on the right side, which is the new situation, which is happening in 2020. So in 2020, we don't know how many quarters there will be, so that's our unknown. And then that total number of coins is going to be 25 billion. So again, this could look a number of different ways. You could have 100 over 12 equal 25 billion over Q. Or you could do that type of situation that we talked about where you have quarters compared to quarters equaling coins compared to coins. So you could have 12 over Q equals 100 over 25 billion. Because remember, the 12 and the 100 are tied together. They're from the same situation. Or this could even be flipped. And you could end up with Q over 12 is equal to 25 billion over 100. So a number of ways you could set up these proportions. And then you would go ahead and solve with that cross multiplying like we've talked about. Oops. Okay, so hopefully that is enough to get you started with that homework. If you have any further questions, let myself or Mr. Kashi know, and then we will be able to help you guys out. Whatever class you're in, you just let us know. We'll get you that extra help. And yeah, so good luck. Thanks for watching.